Right, when we come to splitting fractions into partial fractions, we will have cases where we have three linear factors. So let's just have a look at the reverse process, which is to calculate 3 over x plus 3 over x minus 2 over 2x plus 1. And we'll deal with this one in a minute. So writing those out, the common denominator is going to be x times x minus 2 times 2x plus 1. So that will be for all three, to plus that one, and then minus that one. Then we've got this 3 here, so we'll put that 3. Now the 3 has been multiplied, sorry, the x has been multiplied by x minus 2, 2x plus 1, so we need to do the same here. X minus 2, 2x plus 1. Then we've got another plus 3 here. The x minus 2 has been multiplied by x and 2x plus 1, so we need to do the same to the numerator. And the 2 over 2x plus 1 has been multiplied by x minus 2 and x, so this 2 must be multiplied by x and x minus 2 as well. Then if we write a common denominator and expand the bit here in red, we're going to get 3x times 2x, which is 2x squared, plus x minus 2 times 2x, which is going to be minus 3x, and minus 2 times 1, which gives me minus 2. I'm just going to multiply this x in, so we've still got the 3. So we've got 3, 2x squared plus x, and same here, we're going to get minus, and be careful with the minus sign. We won't change the minus sign at the moment because we haven't taken that minus 2 into the bracket. Next step is we're going to take those numbers into the bracket, so we're going to get 6x squared minus 9x minus 2 when we multiply by 3 plus 6x squared plus 3x. Now we're going to have minus 2x squared plus 4x. So just need to be careful whenever we take that minus sign in, that becomes plus. Writing down the same thing, so we've got 6x squared plus 6x squared, which is like 12x squared, minus 9 plus 3 plus 4 makes minus 2x. The minus 6 is left on its own. Now there is a common factor of 2 on the top there, so we're going to have the same denominator. Notice we haven't expanded the denominator, and we just take out that 2, and we're left with 6x squared minus x minus 3. So that's the answer for that. Now in the second case, we've got 4 over x plus 2, 3 over x plus 2 all squared, plus 2 over 2x minus 1. Now we've got this one appears twice, so what we've got here is a repeated linear factor, and this is one of the cases for partial fractions. So the common denominator will just be x plus 2 all squared 2x minus 1. That's going to have to appear 3 times for each bit. So the 4 has been multiplied by, sorry, the x plus 2 has been multiplied by 1x plus 2 and 2x minus 1, so we do the same to the 4. This has only been multiplied by 2x minus 1 because we got x plus 2 all squared here, and this one has been multiplied by x plus 2 all squared. You can always check back, if you cancel down everything, you should just end up with the same denominator. Okay, if you cancel down that, you just end up back with the same denominator. So always just think backwards. So expanding the bit in brackets here, we're going to get, so leave the same denominator, so we get 4, 2x squared, x times 2x minus x plus 4, which is 2x squared, plus 4 at 3x minus 2. We've got a minus 3, 2x minus 1, plus if we expand x plus 2 squared, we get x squared plus 4x plus 4. Taking those numbers in now, so just doing it bit by bit, we're going to get 8x squared plus 12x minus 8, minus 6x plus 3, so I've changed the sign there, plus 2x squared plus 8x plus 8, and then collecting up like terms. So we got 10x squared, 8x squared plus 2x squared, 12x minus 6x plus 8x gives me 14x, so it's 12 minus 6, which is 6, 6 plus 8, which is 14, and that minus 8 and that 8 will cancel out. Notice the way I cancel, and I've got a plus 3 here still left over. And that is the answer. So here we have the case where we have a repeated linear factor. What we're going on to do is taking that, can we get back to that? This is what partial fractions is about. I hope you've understood, and I thank you very much for watching.